An aromatic reaction. So as an aromatic reaction, the aryl halide don't undergo SN2 reaction. They don't undergo. The CCl bond is a plane of the ring as the carbon atom is trigonal. So now I show you how the carbon atom is trigonal. So if you see this carbon atom, this is trigonal like that, three corners. So the CCl bond is in the plane of the ring, as the carbon atom is trigonal. For attack from the back side, the nucleophile has to go inside the ring and avoid the carbon atom, which is not possible. So nucleoside has to go inside the ring here and convert the carbon, which is not possible. So what is it going to do then? For the attack from the back side, the nucleophile has to go inside the ring and convert the carbon atom, which is not possible. SN1 reaction would involve the unaided loss of the leaving group. Unaided loss of the leaving group. Unaided loss. This is leaving group. Unaided loss. I mean, there is nothing, no aid. There is no help. The SN1 reaction would involve the unaided loss. What kind of loss? Unaided loss. There's no aid available for the loss. So you're going to remove chlorine, no aid. In the formation of an aryl cation. So aryl cation will be formed. Here you will see that if chlorine leaves unaided loss, SN1 mechanism we're talking about, C will be cation, and aryl cation, which is possible but very unfavorable. It's possible but it's very unfavorable. Then what is favorable? Well, I showed you the mechanism. Now if you do see here, what is this mechanism? Then what is this? This is a chlorine, and this acetyl dimethoxyacetyl. I have ethyl here. And then what is going on? Here you can see is this one amine and just form a bond, and these pi electrons go on this carbon. You see here a negative charge, and this negative charge now comes down and chlorine just leaves. So that's why it's form a double bond and chlorine. You don't see chlorine here, chlorine is here. That's what happened. Now we talk about nitration. This is a nitration reaction. On the top you see this is nitric acid, HNO3, H2SO4, chlorine, NH2 here, nitrogen in front position, this is NH, and this is my 6-chloropyrimidine. I have nitric acid, I have sulfuric acid. Now what I do have is nitro, Na2 and Cl. How did that happen? Let me show you. You see this reaction? Yes, what is it? This is nitric acid, this one, NO2OH, this is HNO3, but I have written here like that, NO2OH. What happened? This is sulfuric acid, sulfur, one oxygen on the top, one on the bottom, and you see OH, H2SO4, sulfur forms 6 bond here, 2 to 4, 1, 1, 2, 6. Sulfur has outermost shell 6 electrons, total 16. That's what do you see here is a 6 bonds total. And what happened here? This is nitric acid, NO2. OH was nitric acid, but one proton forms the bond here. And this is O, is now plus. This is protonated. And what's going to happen is nitrosonium ion going to form 2 oxygen on each side, and it's going to be plus because it's a 4 bond total. Nitrogen total forms 3 bond, but here it is forming 4. That's why it is nitrosonium. And what else you do see? This is hydrogen sulfide, sulfur, 2 oxygen up, 2 down, 1 OH, 1 O negative. What happened now? This is nitrosonium ion. 2 oxygen. Each oxygen has 2 lone pair and 2 bond. Oxygen total has 6 electrons in the outermost shell, and so that's why 2 electrons is using the 4 electron left. So total 6 electron. What happened? These pi electron form a bond with N plus, and what will happen then? If it forms a bond with N plus, these pi electron will form a bond, the plus charge you will see here, double bond here. And on one side is a single bond, a negative charge on that side. Now this water takes up this protein, and what happened then? These electrons form a double bond, aromaticity again. This is nitration. You see hydronium ion. Yes, so this was the what happened. I show you another reaction. Well, if I show you this reaction, this one, what is this? It's the same kind of reaction, just amino acetyl. It's just forming a bond here. A negative charge at the top. That's not come down. Current just leaves, and you do see here this one. Okay, okay, well done.